Hello, my mathematicians. This is Miss Foster with Math in Focus, Grade 4, Chapter 3, Lesson 5, Real-World Multiplication and Division Problems. We will be working through two examples together, one in which we are already given the bar models and our job is to interpret and use them, and in the last problem we will draw bar models together so that you will be strong in being able to visualize your math and make greater sense of word problems. So let's take a look at our first problem. Mrs. Romero has $3,756 to spend on equipment for the school media room. She saves $650 for later purchases. She spends the rest on 12 monitors and some software. These monitors cost $205 each. How much does she spend on software? In this first bar model, you can see that this length right here represents all the money that she has to spend. And here is the part that she is going to save. This looks like a subtraction problem to me. If I get rid of the savings, I'll know how much she actually spent at this time of this problem. So I'll do some subtraction. I'll start in the single ones place, the smallest place of value, just in case I have to regroup. 6 minus 0 is 6, no regrouping there. 5 minus 5 is nothing, no regrouping there. 7 minus 6 is 1, and 3 minus nothing is 3. So I didn't have to do any regrouping. Well, we took care of that step easily. So altogether, she spent $3,106. But now we need to figure out how much did she spend on those monitors? This looks like a multiplication problem to me. If each monitor is $205 and she bought 12 of them, how much did they all cost? So let's do some multiplication just like you learned in this chapter. I'm going to put the single ones on this row. Just give a little abbreviation there. 2 times 5 is 10. I'm going to regroup that 10. 2 times nothing in the tens place is no tens except for this one. And 2 times 2 hundredths is 4 hundredths. Having taken care of multiplying the single ones place, I'm going to check it off there. Some people like to do that. I'm going to put my tens on the next row down. I will show it as the tens place by putting a placeholder 0 in here because, dude, I'm multiplying tens. 1 times 205 is 205, but that handy 0 right there helps push everything over into its correct place. Now, I analyzed 12 into single ones and tens. Now I have to put it together to get my complete product. 0 plus 0 is 0, 1 plus 5 is 6, 4 plus nothing is 4, and 2 plus nothing is 2. The 12 monitors costs $2,460. Now that I know how much the monitors were, I can take it away from the total that she spent today to find out how much was spent on software. It looks like another subtraction problem. After all, if I take all this stuff away, I'll be left with just the money for the software. So let's do some subtraction. I'm going to start in the smallest place of value just in case we have to regroup. 6 minus 0 is 6. But can I do 0 minus 6? Not in positive numbers. And it does matter with subtraction, the order that we go in. I can't say 6 minus 0 is 6 because that's not what this says. That's okay though, I know how to regroup. I'm going to take away this 100, leaving 0 hundredths, and squeeze it in here as 10 tens. 10 tens minus 6 tens is 4 tens, and uh-oh. Can I say that this is 4 minus 0? I can't. I've got to go in the right order for subtraction, and I clearly don't have enough hundreds, but that's okay. I can go get some hundreds from the thousands place. 10 hundreds from one single thousand added to no hundreds will equal 10 hundredths. 10 minus 4 is 6. And 2 minus 2 is 0. I didn't even need that comma right there. So when we subtract 2,460 from 3,106, we have $646 left over. Notice again how the textbook can break this into teeny tiny steps. You don't want to trip over them, so take your time and understand that they just really want you paying attention to the details. I had to put 646 here, I figured it out here, and I also spent it in the final answer. All great word problems are solved with a sentence. So this one says she spends $646 on software. Given all the models we've read and all the work we've done, that makes sense to me, but putting it back into that sentence can really help you make sure. Let's do a problem now where you have to draw the bar models for yourself. Tim and Ali had 96 marbles altogether. Tim loses 24 marbles to Ali during a game. I believe when you play marbles, you have a chance to take marbles from your competitor. Now Ali has twice as many marbles as Tim. How many marbles did Ali have before the game? The problem with word problems are the words, and boy does this problem have a lot of them. But to get me off to a good start, I first figured out what we are counting here. In this case, we're definitely counting marbles. And who has things in this problem? Well, Tim does and Ali does. And of course, mathematicians love to abbreviate things. That's why there are digits. So I have abbreviated Tim and Ali. The next thing I do when I'm drawing bar models is I start them off equal to each other. Now I'm ready to reread and redraw the problem, adding details from the rest of the story. Tim and Ali had 96 marbles altogether. Stop. I'm going to show that the total number of marbles right here is 96 by drawing a big bracket out here. The total number is 96. And I think it might be helpful if I move that in here and give myself some space to work later. Tim loses 24 marbles to Ali during a game. Oh dear, I'm just gonna take 24 of Tim's marbles here and just say that they're gonna go down here. These are the ones that he lost. And I can write that there so I know what's going on with my bar models. I'll also go ahead and draw that amount right here. Okay, now Ali has twice as many marbles as Tim. Whoa, I need another color for this one. So we're saying that this is one part and this is another one, and here's Tim's right here. The red boxes here will show me that Ali has twice as many marbles as Tim does now. Whoa! So the question is, how many marbles did Ali have before the game? That would be this amount, the original box, right here. Wow, I think this is going to take more than one step. But it seems to me that if I look at these red boxes, 96 is being divided into 1, 2, 3 equal parts there. So I think I will begin with 96 divided by 3. It's a good thing we learned all that long division, isn't it? I'm going to start by dividing the tens place. 3 times 3 equals 9 tens. All right, so in each of these red boxes, we will have at least 30 marbles. If I take those away, I'm left with 6. Let me divide these single ones. 3 times 2 equals 6. And so that tells me that every single one of those boxes has 32 marbles in it. So now I know that each one of these red boxes has 32. How much does Ali have at the end? Ooh, I could do that as 32 plus 32, but we're just coming off of a chapter on multiplication, so the wise mathematician will practice that. 2 times 2 is 4, 2 times 3 is 6. So it seems that all that Ali had at the end totaled up to 64 marbles. But then I have to remember that Tim started out with 24 more marbles than he started with. So I'm going to take 64 and subtract these 24, giving them back to Tim, and doing that will help me figure out how much Ali had to begin with. Whew! All right, so I realized I need a little bit more workspace, so I moved our first two equations off to the side. We're taking all of Ali's marbles at the end of the game, and we're going to subtract the 24 marbles that he won off of Tim so far. When I do that, 4 minus 4 is 0, no regrouping there, and 6 minus 2 is 4. And so now I know that at the beginning of their gameplay, Ali had 40 marbles. Now I wanted to express my answer in the form of a sentence written with words because this is a word problem. I also want to go back and reread the question. How many marbles did Ali have before the game? I'm going to use some words from here to write my sentence. Ali had 40 marbles before the game. And I might go back and say, well, we did this division to find out what each of these red boxes was. We did some multiplication to find out how much Ali had at the end of the game. And we did more subtraction to figure out how much he had before they even started playing. Friends, bar modeling for multiplication and division and for word problems is such a strong strategy. I can't wait to see how strong you're going to get with more and more practice. Thank you for playing math with me. I love playing math with you. Bye-bye for now.